Hey, awesome. Yes, thank you. Thank you for that. It's a very fancy title, but it's basically going to be my journey through doing development for FujiNet since I started working on the project. I'm a professional developer by trade. I work on microservices, e-commerce systems, so this is a complete far cry from that arena, and all my work colleagues thinks this is quite an amusing pastime that I'm partaking in. So with that, it's going to be very much focused on FujiNet. The FujiNet is a fantastic little platform. Tom will tell you all about it over the next few days. We've got a lot of development classes going on at the moment, so if you want to see it in action, the classrooms are all doing basic assembly and various other parts to have a look at. So what did the FujiNet do for me? It very much reignited my passion, as was said earlier. No, that's the next click. I had an Atari 400 and 800 back in the day. I was using Mac65 Action for programming that. Those were probably my first two purchases of languages as a little 13-year-old on the phone to somebody in America, get my parents' credit card to pay for Action and get it sent all the way over from the US was quite an experience for me. At university, I did a maths degree. So back then, fractals were very popular. I'd taken my Atari 800 XL and I was showing all these things off, so that was kind of nice to do as part of my maths degree. I was printing out, I had what was the old printer, 1024 or something like that? 1025. Took that to uni with me and I was printing out fractals on, putting them up in halls and residence in 4-color grayscale things. Again, my colleagues thought I was mad, I think, at the time. In the 2020, I think it was, I was looking out for projects to do as part of lockdown. Lots of things were going on, so I suddenly decided I would get back into retro 8-bit computing and managed to get an 800 XL. And oh yeah, I went on to I bought that back in September 2020 and maxed it out with a ultimate 1 megabyte. I don't know if many of you know what the Atari platform's like, but there's a lot of hardware still being developed for it. Absolutely fantastic things can go on there. The Sophia 2 gives me DVI output, so I can go straight to HDMI on it. It's absolutely superb. Little 12-year-old me is very jealous of the things I can get on it now. And in October 2020, I joined the FujiNet group by buying one off some retro computer seller. Mine's bright red. It's a really, really, really bright red one, the first one I got. So yeah, I discovered that and joined the Discord, and I've been annoying them ever since. FujiNet is an open project. Its firmware is written in C++. It's a Platform IO target. My C++ was a little bit rusty. I am a Kotlin and Java developer, so JVM is the platform I've been using for the last 15 or so years, maybe even longer, I think. It didn't take too long to understand the structure, though. It's quite well structured in terms of bring-ups for new devices. The structure is very strong for that, so we can add new hardware very easily and bring in the ideas of all the previous boards. So from a firmware point of view, it does that quite easily. From a coding point of view, it's great. It's a project on GitHub. Download it, compile it. I wrote a build system for it as well. Build script to help build it for any platform. And you just plug it in via USB and flash your firmware. Absolutely simple thing to do. So if you want to change all the messages and develop new features for it, it's there and it's available. Very easy to contribute to, as I say.
Not all of us know exactly what FujiNet is.
Okay. Tom. The FujiNet, it's basically a device that you can plug into old hardware that will it's an ESP32 processor on board, and it does all the lift and work for modern day protocols, HTTP, HTTPS, FTP, SSH, all of the different network bridging that you need to do, all of that TCP stack. It will take that on for you, and you...
I'll do the quick one here.
Go on then.
Okay.
Do you want the mic?
Virtual disk, virtual printer, virtual modem, network adapter on a device that's less than $100 for a number of different platforms.
So what comes out the back end that goes to your microprocessor?
Depends on the platform.
Okay.
So basically there are, for each one, we do a hardware-specific bring-up for each target bus. So for the Atari, it's SIO. For the Apple2, it's IWM. For the Coleco Atom, AtomNet, and so on, and so on, and so on.
Okay. I've been using Raspberry Pis for that, so, okay.
Much smaller, much faster boot up. Not as fast, but the ESP32 is fast enough to do TLS, to do crypto, and to do all the protocol offloading. So it makes a usable network device. I'm gonna stop there.
So yeah, there's going to be a lot more on that from Tom's side of the world. For me, this is very much more the software journey and how I'll go into it now. So we've got the hardware side. We've got the C++ firmware, platform I/O, as I mentioned. On the host side, the host applications need to talk to that FujiNet. So as Tom was saying, it's SIO calls for Atari, IWM. We've got Meatloaf being combined in as well for the Commodore 64. So what the host software, though, has to communicate to that FujiNet to get that data up and down. I think I've spoken to some of that. So this is a bit where I talk about myself again. So yeah, as somebody who's been doing JVM for over 25 years, the standards on the host's applications were not up to what I would actually expect. I'm a test-led, agile developer. We have paired development, and all that modernism is there for me. So when I came to FujiNet and I looked at some of the applications there was a lot of repeated code. It's very difficult to write simple applications for, and I felt that was an area that I could really contribute to the FujiNet, is to kind of bring that software development side of the world that I've been exposed to into FujiNet itself. A lot of the applications are very much toys in a way. They're in the FujiNet apps directory. They're exemplars for the things that we want to do. So there'll be a Mastodon client, and it literally goes and gets one message and prints that out. And so that exemplar would then be copied across to lots of different applications. So they're there for illustrative purposes. One of the other things as well, some of the development there wasn't really cross-platform per se. There'd be an example in Atari, and there'd be an example for Apple2, and there'd be examples for other platforms as well. But they were in separate directories, and they would be separate code bases because they had to deal with SIO or they had to deal with IWM separately. So it was very difficult to write generic applications that could just use the FujiNet. And that's what I wanted to do. I wanted to bring a common library to the platform, something that we could use so that you could write one application, run it on many devices. The first version of the library was to capture the FujiNet communication. So there's an application called config, which runs on all of the devices that we bring up, because that's the one that configures the FujiNet. The FujiNet has to be told what hosts you want to connect to and what devices you want to mount. So what disk. So you could pick an ATR disk for an Atari or a PO disk for an Apple, and you can mount that into a slot, and then you boot your machine, and it thinks that disk is local, and it just boots off it. So exactly like you shoved an old floppy in, you can boot straight off hardware, straight off an image of a TNFS server on the internet, and your machine just thinks it's booted off a local disk. That's kind of the power of it. So every application has to have some kind of config to allow you to configure it to say, this is the host that I'm interested in, and that's the image that I want to have mounted. So that part of the library was the first thing that we ported. And yes, we needed a common library, so FujiNet lib was born. The first version of it was FujiNet IO. Then we started a discussion about, well, we've got this thing that Tom will talk about, a network adapter, and there is the concept of a network IO, NIO. So we wanted to have a network library, so things like open a URL, fetch some JSON, do a HTTP request, all those things that an application would be really useful to have for all platforms was things that we didn't have really simply that you could write. So that's what I wanted to write, FujiNet. So the FujiNet lib was born. Initially it was Atari, and we then extended it onto Apple. The function list was, we came up with the protocols that we wanted, open, close, status, read, write, things like that. And that was written down as a kind of header library, and then about 6 months went by and nobody had done anything on it, despite us having that conversation, so I decided to pick the challenge up. The network library was the first thing that came in after FujiNet IO. That was for Atari, again, because I've got an Atari, that was quite easy to do. And we decided that instead of calling it FujiNet IO, we would call it FujiNet lib. So FujiNet lib was the eventual version of what we are building now. The purpose of it is to support all the FujiNet capabilities. At the moment, we've got 2 devices, effectively, the FujiNet itself for config and the network stack. Obviously, it's got lots of other devices on there. We've got modem, CPM, clock, various other things that we can do. So those are the things that we're going to start bringing in the future. More of the things that the FujiNet can do in standard library so that any application can be written for that. So we wanted that to be cross-platform, and we needed a framework that would support multiple platforms and be reliable and easy to use. I don't know how much development people have done on those platforms, but CC65 is probably the de facto platform for multi-platform 6502 development. I did have a look at different languages and different assemblers when we were in this phase. I think we chose C because it was a fairly universal language that most people could pick up fairly easily, and because CC65 was there. And my initial thoughts were that it's quite a bloated framework. It has got a lot in it. But it does support a lot of platforms, and actually it's not bloated, it's just got a lot of flexibility, and I didn't understand it at the time. So I actually wrote an entire new version of the config application for Atari in assembly on CC65 just to learn 6502 assembly, because, it's fun. Yeah, why not? And so I've got my own version of config, which I really enjoyed writing. So that was the platform we decided to use. It supports many 6502 systems, and because it does cross-compilation, you can run it on your PC. I can have Visual Studio or Visual Code running, and I can compile down using any modern tools. It runs on Linux. I've got it running on Linux and MSys2 and WSL2. I don't bother running it in PowerShell on Windows because I think that would be too much pain. It's been around for decades. It really has. We had an issue recently with an update from CC65 itself, added time.h to the standard Apple2 header, which broke one of our applications because we were defining an object called time there. And I looked at it thinking, oh, have they just introduced this time object? No, it was introduced 21 years ago. They just didn't link against it from the standard header. So that was quite an interesting thing to find. We've also got quite a lot of resident experts in C65 within the FujiNet group. So, and as I say, it supports both the SEM and C directly. You can either do embedded as SEM in your C, in which case I want to shoot you, or you can write S files directly and just compile those yourself. However, yes, I think this is a topic as well I could probably talk about forever. I won't, but testing, it's very, very high in the things that I want to make sure are done on any platform. C++ is difficult enough to test on its own, but for me, writing a library for targets that I don't have was very difficult. I don't have an Apple2 or didn't have an Apple2. So I wanted to find a testing framework that would allow me to write C or assembly code in 6502 and be repeatable and testable. So we found something called BDD 6502. It's a Cucumber framework. It allows you to write standard Cucumber BDD tests, which are behavioral-driven development tests. It uses it's a JVM application, and it uses the Simmons 6502 emulator for 6502 itself. So it fully supports lots of different elements of 6502. And I can write calling extensions for it. It's absolutely fantastic. It kind of bridges all the things that I want to do together. So if I want to develop a new command within that BDD testing, I can write it in Kotlin or JVM and have that tested as well. So I've got my testing framework tested, which is all very meta. So yeah, I ended up writing testable 6502 code with BDD tests. Here's an example of one. Is that all fully readable? Yeah, so here you can see we've got a test scenario. The outline is that I'm going to test a function called network unit, which basically tests that any string that's given to it, the return value from that function is going to give you what the drive number was. So you can see my examples down, actually, that's a little, okay, there's some numbers at the bottom there that's 2s and 3s, but it's too big for the screen. Sorry. But we can see this is a scenario outline. It will initialize an application, compile that application in the BDD, into the BDD 6502, fire up a Simmons 6502 emulator, and actually run the code itself. And you can see the trace of the 6502. So you've got this immediately testable set. You can test all of your changes immediately with a test. You just run it. There's a web interface for it. Most of the 6502 assembly is in assembly for this because I wanted it to be as fast as possible and as lean as possible because it's a library. It caught lots and lots of bugs. My 6502 assembly goes back to when I was 12 or 13, so I haven't really done very much of it for a while. And this saved my bacon so many times. And I find it absolutely invaluable that I have repeatable tests that I can test my 6502 changes instantly. I don't have to fire up any further emulators. I don't have to run it on real hardware. So all of the problems that Tom was saying about development of having to wait 20 minutes to just compile each of those sections and put them together and put them onto tape and then have them burnt into an emulator, into ROMs and EPROMs, and have all those tested, my turnaround is seconds instead. So I could just fire up a browser, change the test, rerun it, and it's off. And as I say, I can watch the code as it runs. Here's an example of one of my screenshots of me doing development. Top left, you can see the actual code for the library. That's the 6502 assembly. On the far right is the BDD test itself. So this one is, why have you done that? Go away. The BDD test itself, that is testing that all of the all of the values are being set in the locations that I expect them to. This is not... Why are you playing up? Don't touch it. I don't think it likes my assembly. And in the bottom left-hand corner, you can see, I think it's being...
Did you test pass for that code? Or?
Yeah. Well, that's the next screenshot, funnily enough. There. Let me hold that, see if that helps. And there you can see the Simon emulator, the 6502 emulator at the bottom left-hand corner, actually stepping through each of those instructions when it works. Oh, that's unfortunate. And here is the test itself. Green. It's all green. So that you can, and the great thing about this framework as well is if it does fail on anything, it redlines at the line that it failed on. So you can go back, realize that where the memory wasn't working correctly or wasn't set correctly, it comes up red, I can go and fix that, and immediately I can rerun this test. So you can see the test suite up there, you can run that, or you can run the individuals, or you can run the individual function itself. So you've got so much flexibility in the testing framework. So the first target was Atari. That one's easy. I've got an 800 XL at home, fairly souped up as I mentioned. It means that I could start developing applications using the library. I could write both tests virtually within BDD. I could test them with Altera as well. So there's a very, very good Atari emulator that we can use for that. So I can get those up and quickly, running quickly. Altera, if you've not come across it, is an almost perfect 8-bit Atari emulator that you can just throw pretend hardware at, and it will give you everything. One of the greatest tools for doing Atari development that's ever been built, frankly. I have a strong background in build systems. I generated a build system for ATG platforms back in the day so that they could be deployed out as web applications out to multiple targets, SSH, all those kind of things. So I always make sure that my build environments are very well done. I've got make files for all those. So I can run a make command, make test, and it fires up the emulator, loads up the application that it's just built, and steps through it. It's a lovely little environment. As I say, combined with there's an emulated FujiNet as well. We not only have the firmware code, but we've also folded in, thanks to the great work of APC on Discord, the FujiNet PC side of the world, and we've also extended that to Apple2 as well now. So we have emulated FujiNets running on PCs and Linux that you can connect to, and it will do all of the functionality of the FujiNet without actually having to buy the hardware itself yet. So if you just want to try stuff out, we've got it all virtualized. And as I say, it allowed me to iterate over changes very quickly. Second target, the Apple. I kind of stumbled across this one. The Apple2 was really kicking off in the Discord. I wanted to get involved somehow, and obviously having done a library, you kind of want it for more than one platform, otherwise it isn't really a cross-platform library. So I got involved with the Apple2. I only had two immediate problems with that. One is that there's no emulator, so it's very difficult to, there was no emulator at that point. So we had no FujiNet virtual support, so you'd need real devices, and I'd never even seen one. I had never come across an Apple2 in my life. Virtually none in the UK at all. In the UK, the computer of choice during the 80s was the BBC microcomputer, the Beeb. That was the one that most people had at schools. I've actually brought one of those over from the UK and given it to Tom, because we wanted to do that as a bring up soon. The UK doesn't have many A2s at all. I've seen various talks on this as well, where people have gone around the room and said, "Have you ever even seen an Apple II? And it's like, no, never seen one. The only way I had access to them was actually expensive eBay imports. I'm sure all of you know that there's like a 1,000% markup on anything that you want to buy in the retro scene on eBay. So that was kind of out of the question as well. And that kind of meant that I had to write the library for the Apple II kind of blind. I had the BDD tests, so that was great. I just didn't have any access to real hardware. So how was I going to test it? Fortunately, one of the chaps you'll see knocking around, Ben, Super Ben K on our Discord, was an amazing help. I would upload a disk file to Discord with my change on it, and he would run that. Actually, it was just the executables to start off with because we didn't have disk support. He would run that on real hardware. There was a bit of a time zone difference. It really did feel like I was back in the 60s, and some of the stuff that Tom's talked about with punch cards, having to wait for your application to be run, somebody to tell you what the results were. And it was all screenshots and logs, and did we have a better solution? Well, we've already got Altair and FujiNet PC, so I thought, well, why can't we build some similar functionality for the Apple II? So I started looking at AppleWin and giving that FujiNet support as well. We've already got one member of the team, Eric Carr, who'd kind of shown the way on that. He's one of the authors of some of the 5-card stud stuff that you may come across with the FujiNet. It's one of our exemplar applications for multi-platform, multi-computer games that you can run over the internet between different platforms. It's a lot of fun. He had already written some extensions for the AppleWin emulator that allowed him to test the app keys work. So we have various JSON bits of data coming up and down the network to support applications, and he'd written that into the AppleWin. I was going to be a little bit more ambitious than that. I wanted to add full FujiNet PC support, the emulated FujiNet onto there. So I started letting everybody know that I was doing this work, and I'd started a proof of concept for it, just making the changes to AppleWin itself. It's another C++ project. Oh yeah, and I eventually came over to the US last December and picked up an Apple II, finally seeing one for the first time. So yeah, Andy Diller, who you'll see knocking around, he kindly offered, because I was having so much trouble trying to get my application running, and Ben wasn't always available, given that he's in a different time zone, and he had one spare. So the only problem we had with that was that to send it to the UK, it was going to cost him $800 just to send an Apple II over to London. So I decided to come over instead. Flight was actually cheaper to come over, pick it up by hand, and take it home. And also I got to experience Philly cheeses, so that was something I'd never had before. So, that was well worth the $800 price. So I managed to pick one up last December. Around about this time as well, Oliver Schmidt, who's one of the people on our forums who's had a lot of CC65 experience. He's an Apple II guru. He's many years supporting CC65. He's doing a A2 RetroNet and A2 Pico, so they're cards for the Apple II that you can use to do bridge the gap using Raspberry Pi Picos to do networking and various other things. They're very worth looking into on that one. For instance, the A2 Pico I've got currently running as a soft SP, so it's emulating the SmartPort controller on my A2, and I use that to connect to real FujiNets. So very useful card. You can just flash it with different Python code at No, is it Python? No, he's using C. He's using C, but you can flash those very easily to run whatever you want from the Pico. Yeah, he knows so much, and I knew nothing. You imagine I've never even seen one. I had no idea what the Apple II was all about, so I needed some support on that one, and he was very patient. He proposed that we would write SmartPort over SLIP. This was very much to tie into some of the work, the future work that we're doing to do serial between the FujiNet and the Apple II, and to support some of his cards, and so it's future direction. So if I implemented it in the way that he wanted, it would support his future work, and it was no skin off my nose to do something that would help. So yeah, he carefully and slowly explained how I/O works on Apple II for me, and so I implemented it while on holiday in France with my wife. Fortunately, she's very supportive of my endeavours here. It's actually her birthday today. So, yeah. She does want to come over for any future talks I do, though. If I do come out here again, she wants to come over because she's seen what the shopping's like in Philadelphia, and she quite fancies doing that in revenge for me leaving on her birthday. So AppleWin, we used AppleWin as the emulator. It's both functional, extendable emulator. Again, it's more C++. It's got a direct Linux port as well, which I found out later as well, which we now have. So we've forked both the AppleWin and AppleWin Linux emulator repositories, which are basically forks of each other anyway, or the Linux one is a fork of the main one. And we've extended that to add the FujiNet PC. So no more punch cards. This is great. I can actually write my applications on an emulated Apple using the emulated FujiNet, writing a library which I have emulated the 65024 for to run my tests in. So there's a million layers of virtualization going on here. And we can start writing proper cross-platform apps for Apple II and Atari. I've got several exemplars. We've got 5 or 6 different demo applications now using this library. Stripped out a lot of the boilerplate code that we had in a lot of the applications to just use the library now. So we've got that commonality. It's reduced, as you know, when you're on a 6502 platform, you want to reduce the footprint of your applications down as much as you can. So that's helped massively with things like config, where we're really struggling with memory on that because of the amount of functionality it does. We knocked 2 or 3K off the executable, which is quite fantastic for the functionality we want to support, which means we can get it to do more as well. And yeah, there's no 8-bit computers needed anymore because we can do it all virtually. So.
And all within the context of an automated pipeline for this.
Indeed. So first iteration, the FujiNet PC and the extensions to AppleWin, first of all, was just to support the FujiNet device. So the commands that were needed for config, there was absolutely no way I knew anything enough about SmartPort to be able to add that straight away. So the initial iteration was just to get it to talk. I absolutely didn't. I knew nothing about it. But we could write apps. It meant we could do the library. It could do the communication with it. We just couldn't do things like disks. We couldn't mount disks. We couldn't do those type of things. Second iteration was definitely to support the SmartPort, which is what we've got. A lot more back and forth. How does this work? Fortunately, the firmware that you have to write, this is another layer that's quite interesting. The Apple has to have firmware to understand the hardware devices that it's connected to. So all the C000, CN00, all those type of things. I had to learn all about that. How to do that? Well, within the context of AppleWin, that was quite easy. I could completely take over because the emulator knows everything about every single byte within the virtual Apple II. So all I had to do was write to one address, kick into the C++ code that I'd written, and then that could talk to the FujiNet PC and do all the communications and then pass it back. From the Apple2 Emulator, one cycle instruction had gone by, and it had downloaded everything it needed for that read operation, the disk operation, and all of those different things. We had a lot of back and forth, and eventually, on exactly 25th of January, because I looked it up, we finally got SmartPort disk support added to that, so we were able to boot up the FujiNet config, which was an absolutely huge piece of addition to our toolkit. And then it went off. Oh, there it is. So that's the config on Apple II, and that is it running within the emulator itself. Normally you wouldn't see that on an emulator, but now we have it. So you can boot in, load up the disks. We can do apps. You can see in the background there's our, that is a screenshot of the emulated ISS tracker. We can boot disks over the internet in exactly the same way. The emulator can run the applications. Everything's bootable. So that device is now fully done. There is still more to do. We've got a lot of things still coming up. As I say, Oliver's doing the A2 Pikachu? I don't know. We have an opportunity to start bringing out the serial connection. We've got CPM and clock on the A2 yet to implement. There is a lot more platforms, so if we extend the idea, it's not just Apple and Atari, but next I want to do the same thing on Vice for Commodore, so that we'll have a virtualized FujiNet PC talking to a virtual Commodore 64, and then I can extend the network library for that. Then we'll have applications that run across those three platforms from one common code base. I mean, it's just, there's so much that we're going to be doing in the future on this. This really is the beginning. Having that set of standard network libraries means that people can write simple applications. It's no longer having to understand how FujiNet works and having to copy all of the code that allows you to talk to that. You're now just running one simple function like network open, network get, network post to do any of that HTTP commands, and you can just specify that. And that's that's the host application able to open a HTTP URL, go and get that data, bring it all back down. That's what the FujiNet is doing for you. And this side of the world bridges that so that you can have a common library that means that the applications are really simple to write. For instance, just last week or maybe the week before, we introduced Kontiki, which is the web browser. So that's now running on Apple II and Atari. We've got it so that the Apple II enhanced mode even goes into 80 column. So we can just, same code base, literally just change the target name from Atari to Apple II. Application works straight off into that target.
And Kontiki, I will also add too, that Kontiki started live on the IP65 stack, which was a TCP IP stack for much smaller, less capable chips. But this was actually done to prove the point that we could take and build the bridge not only between FujiNet applications, but also bring in things that have been well tested and worked in the past and bring them into the FujiNet fold as well.
Yeah, so the benefit there is we can just completely remove that stack from the host application. It means that the Kontiki web browser application itself, a large chunk of that application is just how to deal with network. We don't need that anymore.
More than 35K was more than 35K was just the IP65 stack.
Yeah.
That's now gone. That's
Yeah.
now that's running on the FujiNet.
And so we can start adding additional functionality that matters to the application. We don't want 6502s having to emulate stacks, so the FujiNet can do all that for us. My final musings, because it is 22 and I need to shut up soon. what a journey. It's taken me from a complete Apple2 novice to a not so complete Apple2 novice. It is extremely satisfying to produce applications using modern software, all my framework there, the testing, and to see that application actually running on real hardware after you've compiled it down, transferred it across, and run it via a real FujiNet onto those devices. It is extremely satisfying. From 12 to 55, yeah, I never thought as a 12-year-old this is the kind of thing I'd still be doing when I was 55, but here I am, and I'm enjoying it a lot. I nearly swore. I won't do that. You can try your curiosity out. We have it all virtualized, both on the emulator for the host and the emulator for the FujiNet. Both sides are there. We have that. If you want, there is a virtual machine that Ben has produced, a VM image that you can download. I think is QCOW and
VMDK.
Yeah, VMDK, so you can download that file. That has both Atari and Apple, both sides on there, so you can fire those up, try out some applications, just have a play around with it, even just use it as a device, connect to the internet, download any of the games that you fancy that are out there and boot those directly up into the emulators for yourself. And as I say, we're just starting. There's just so many more targets out there. Coco, we've just been chatting to some people about Coco today as well. We've got, I bought a Dragon 32. My hardware stack has suddenly gone from 0 in 2020. I bought 3 BBC B computers, 2 of which I bought 2, gave one to Tom, my uncle gave me one. I've got a Spectrum, Commodore 64, Dragon 32, Apple II, and an Atari 800. And these are all devices I want to get that library working on. This is all things I want to get that software working on. We want to build FujiNet for all of these things. And I'm really excited to do the software side of it. And come and join us. I think I've said that. We have a stand. Come and see us, the 5 years of FujiNet development stand, and please join us. We have a Discord. I may have said that already. But that's it. Thank you very much.
You do still have 5 minutes left for questions. If anyone wants to ask a question, I'll hand the mic over.
I should have talked slower.
So many questions. So many questions. Apart from wow. So, I mean, I'm just amazed at the disk side of things. Can you talk about how you emulate disks? I mean, I'm thinking Acorn file system is nothing like Apple's file system, is nothing like Commodore or Atari.
I was going to say this side of the world I'm going to have to pass to Tom to. Can we squeeze the microphone between the two of you?
The simple answer there is we have, for each system bring up, we have a bus. On that bus, you attach a set of devices. One of those devices is the disk device. And the disk device has a number of media types that connect to it that handle all of the ins and outs of reading and writing from various image formats. ATR for Atari, PO for Apple II, and so on and so on. So we just make another file system type. It may be a different situation on the BBC. We literally try to do the best possible integration that we can for each target bring up.
So not just it's a block device?
If we need to do it that way, we do it that way. If we want to do something more high level, we do it that way.
So when you're talking, say if you're in the Atari world, when is the communications across the connection to the FujiNet then Atari
Yes.
words? Yeah.
Yes.
It's not.
Atari talks to the Atari bus. The Atari bus takes and talks to our virtual devices.
Okay, so not sort of normalized before
Before it goes to, yeah. We try to do the best possible integration for each bring up, and we tried to build an architecture that could take and facilitate all of these disparate device types. I mean, Jamie back here is working on IEC support through the Meatloaf project and contributing code to us to have our Commodore support for all of our Commodore serial devices.
So is that to sort of
Yes.
increase the work.
Yes. Why would you want a 1 megahertz 6502 to do all the work when you have this big honking 240 megahertz dual core processor with all sorts of hardware acceleration that you can use to do most of the work and just pass a nice clean interface back up to the target machine?
Thank you.
Sorry. Yes.
Yeah. I just had more of a general question as far as your integration. So how much was just your architecture, your design, and obviously others' input, a lot of other people's input, versus, for the example that the gentleman was just previously talking about with file systems, right? Those file systems are, the code like that is in the emulators, right? If it's any modern file system, it would be like, there's Linux drivers and so on. So how much code have you got? If I know it's a really tough question, but is it just a tiny bit of code or only in certain cases? Or did you start with a certain common base that you could deal with? Right, because the TCP/IP stack is standard across everything, right?
Yeah. Well, that's where the firmware comes in and deals with those different devices that you need to do. So anything that is native to that host machine is something that is then catered for in the firmware.
So anything outside of TCP/IP to get to the...
But we can do, TCP is just the stack in terms of be able to do, but we have protocol adapters as well. So you
do have okay.
So you can do it at SSH level. So we don't just call HTTP. You can do SSH, you can do FTP, you can do TNFS.
So
there's lots, all those protocols. And if we need to add a new one, there's a framework for that, and you just plug that in.
Is there room for like IP6 implementation, and when that becomes maybe more prominent?
I don't think IPv6 is ever going to become prominent at this point outside of private networks.
Verizon's pushing it.
But to answer the direct question,
Verizon's pushing it now. I mean, that's what you get by default.
Yeah, it is something that it can be extended out.
Sure.
Yes, absolutely.
Well, in the cell phone world, it's very prominent, right? Obviously.
Yeah.
Well, yeah, and as far as that's concerned, you've got the vendor framework. So, when that becomes an issue, we'll take control of it.
I think my question was more is how much flexibility is in the current existing hardware to implement a more complex protocol?
Well, we have a lot of logic in the microcontroller that we can leverage to the hilt. So
also, we're barely touching the surface of what the ESP32 can do in terms of the.
I mean, obviously TCP stack is not that huge, but
all of that's handled transparently by the ESP32. We leverage the vendor framework to be able to handle that, and we expose that to the target machine through a variety of interfaces. So,
No worries. Any more?
yes.
So, I mentioned CPM as well. That's yet another. We run. We've got the CPM software stack is effectively run on the ESP32.
We had a guy who did an RC 2014 bring up. So yeah.
So it's just anything that we want to throw at it. We've got, as I say, we've got people doing Spectrum. We have Jamie with the Commodore and the Meatloaf. We've got Coco's just another one that's been done. Adam has been done as well. Everything and anything. We want to target everybody.
Atari 2600.
Yeah. Recently we had, last week we were on a stream, a Twitch stream, where people were demonstrating the Atari 2600 connecting to the 5CS server, which is the 5-card stud, demoing multiplayer capability on a 2600, playing 5-card stud. These are the kind of things that we want to be able to offer to every platform. It's a lot of fun as well. It really is. When you get these things just suddenly appear on these old hardware, and you're playing multiplayer games against other people, it's just a good feeling.
It's a blast.
Come and join us.
Please. Come on, we have cookies.
Yeah.
Okay, I think we're about out of time now. We need 10 minutes for the next guys to set up. Thank you very much, Mark, for that informative
Thank you.
talk.